Welcome to edupediaworld.com. You're watching the videos on area of parallelograms and triangles. So in this video we'll discuss some of the more advanced questions related to area of parallelograms and triangles, so which are very important from the exam point of view. So let's get started with the first question. Question number 1. Now the question number 1 says that the side AB of parallelogram ABCD, side AB is produced to any point P. So this is a point P. Now a line through A and parallel to CP meets CB at Q, means this is a line. AQ is parallel to CP. So let's write what is given. So it's given AQ is parallel to CP. Then parallelogram PBQR is completed, means this is a parallelogram. PBQR is a parallelogram. So again it's given PBQR is a parallelogram, right? Now so we need to show that area of ABCD parallelogram is equals to area of PBQR. So we need to prove this. So let's see how we can prove this. So it's very interesting question. Now what we can do is we can join these two lines. Let's say we join AC and then we join PQ, right? So this is a point P. Now so we can write construction is we need to join AC and PQ, right? Now if you consider this triangle ACQ and let's say APQ, let me draw ACQ, this triangle, and APQ, this triangle, right? So these two triangles are equal. Why? Because they have a same base AQ and they are between the same parallel lines AQ and CP. So we can say that area of ACQ is equals to area of APQ. Why? Because they have a same base AQ and parallel lines AQ is parallel to CP, right? Now area of ACQ we can write, if we split this area of ACQ, we can write into area of ACQ as ABQ plus ABC. So we can write area of ABQ plus area of ABC, and area of APQ we can write it as again area of ABQ plus area of BPQ, right? You can see properly APQ can be written as this area plus this area. Now since this area and this area can cancel, so what we get is area of ABC is equals to area of BPQ. Now area of ABC, if you can see, is half the area of parallelogram ABCD, right? As we know according to the theorem. So it can be written as area half the area of parallelogram ABCD, and area of BPQ can be written as half the area of PBQR, right? So this and this get cancelled. So what we get is area of ABCD is equals to area of PBQR. So this is how we can prove these type of questions. So let's move on to the next question. Question number 2. Now the question number 2 says that diagonals AC and BD of trapezium ABCD. So first we need to draw trapezium. So let's say we have a trapezium like this, ABCD. So let's say this is A, let's say this is B, C and D. Now in which AB is parallel to CD and they intersect, diagonals intersect at O. So let's say this is a diagonal AC and this is a diagonal BD, right? So they intersect at O. Now so we need to prove that area of AOD, this area, equals to area of BOC, right? So let's see how we can do this now. So if you can see properly, if you consider area of ABD, this as the area, and area of ABC, this is the area, right? If you can see properly, they share the same base AB and they are between the same parallel lines AB and CD. So we can write area of ABD equals to area of ABC. Why? Because they have same base AB and same parallel lines CD is parallel to AB, right? Now area of ABD can be written as area of AOD plus area of AOB, right? And area of ABC can be written as area of AOB plus area of BOC, right? So this and this get cancelled. So what we get is area of AOD equals to area of BOC. So this is how we can prove these type of questions. So let's move on to the next question. Question number 3. Now, the question number 3 says that in figure ABCD is a pentagon, means ABCD is a pentagon, and a line through B parallel to AC meets at F, right? So this is a point. So we can say that BF is parallel to AC. So first write what is given. It's given BF is parallel to AC, right? So we need to show that area of ACB, so this area ACB is equals to area of ACF, AC and F. So we need to prove that. So let's see how we can prove this. Now we know that, or we can say area of ACB is equals to area of ACF. So if you see properly, if we take AC as base, so area of ABC and area of ACF are equal. Since if we consider AC as a base and AC is parallel to BF, so that's why they are same. So we can say that same base as AC and same parallel lines, right? That is BF is parallel to AC, right? So this is how we can prove the first part. Now so let's see how we can prove the second part. In second part we need to prove that area of AEDF is area of AEDF is equals to area of ABCDE, right? Now if you take this equation 1, if you add area of EEDC to the both sides to the equation 1, so we can say that adding area of AEDC to equation first both sides, so what we get area of ACB plus area of AEDC equals to area of ACF plus area of AEDC, right? Now area of ACB plus area of AEDC, right? So it will come the area of ABE, area of ACB. Let's say this is the area ACB, and if we add this area to this, so it will become the area of this part, right? So it will be area of ABCDE, and if we add area of AEDC to area of ACF, so this will become this part. You can see properly, right? So it will become the area of AEDF. So this is how we can prove these type of questions. So let's move on to the next question, question number 4, which is also the last question of this video. Now it's very interesting question, so you have to watch this question very carefully. Now, it's given that ABCD is a trapezium. So first we need to draw a trapezium. So let's say we have a trapezium like this. So this is a trapezium ABCD, right? Now in this trapezium, AB is parallel to CD and a line parallel to AC. So let's say we need to draw a line parallel to AC intersects AB at X and BC at Y. So means this, we can say like this. So let's say this is a line and this point is X and this point is Y and this line is parallel to this line. Now, so we need to prove that area of ADX. So let's say this area is equals to area of ACY. So it's AC and Y. So let's see how we can prove this. So it's a very interesting question. So it's very important to watch this question. So for clarification, what we can do is we can join the line C and X so that it would be very easy to solve this question. Now what we need to do in this question is, so let's say we can see properly area of ADX is equals to area of ACX. So why? If you see properly area of ADX, so let me use a different color. So let's say this is the color, right? Area of ADX equals to area of ACX, right? So this is area of ACX, right? So you can say that they both have the same base AX and this line is parallel to this line, it's given. So we can say that AX has same base and AB is parallel to CD. So area of ADX equals to area of ACX. So let it be the first equation. Now second equation, we can say that area of ACX is also equals to area of ACY. So why they are equal? So you can see properly area of ACX. So this is the area of ACX, right? And area of ACY is this, right? You can see properly. Now you can see they have a same base AC. So this is a base, same base AC, and they are between the same parallel lines XY and AC. So we can say that they have a same base AC and they are same parallel lines. We can say XY is parallel to AC, right? So let this equation be true. So you can see properly in these two equations ACX, area of ACX is common. So from 1 and 2, so we can write from 1 and 2 area of ADX is equals to area of ACY. So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.